This is interesting. Looks like the exact same learning target as before. Let's see if there's a new twist to solving polynomial equations of degree 3. Ooh, this definitely looks different. This does not look like a factor by grouping. This does not look like a perfect cube. I don't really have any other recourse other than to use synthetic division. Notice I had to put in a 0 as a placeholder because there's no x squared in the original equation, right? There's one x to the third, there are 0 x squareds, then a negative 49x, then a positive 120. Notice I decided to try 5. I know I advise that you normally try 2, however, I know that 2 is not going to work on this one. All right, so I do synthetic division. And again, this might have been my second, third, or even fourth guess because I probably would have tried 2, and then I probably would have tried 3, probably would have tried 4, right? But 5 is one of my solutions. And then the resulting equation, that 1, 5, negative 24 is 0, right? That bottom line from synthetic division, that tells me 1x squared plus 5x minus 24 equals 0. Two sets of parentheses, x times x for the x squared. The negative on the 24 tells me the signs do not match. And while I could try 12 times 2, or I could try 6 times 4, 8 times 3 is going to be the magic combination here, right? 8 times negative 3 makes a negative 24. 8 subtract 3 leaves me with the 5. And so my other solutions, oh, and I lied, 3 would have worked, right? So I could have actually done 3 for synthetic division. Or I could have been wild and crazy and guessed negative 8, although most of us won't do that. But if you tried 2 and it didn't work, you could have tried 3, and then 3 would have worked. I happened to try 5. And so there are our solutions in order from least to greatest. Again, 2 of those solutions came from factoring. 1 of the solutions came from synthetic division. Okay, new equation. And you could actually do synthetic division or factor by grouping on this one. I chose synthetic division. I decided to try 2. And of course, this is going to factor beautifully, no remainder. But look what the interesting resulting equation is. I've got 1x squared plus 0x in the middle minus 7 equals 0. And I'm like, how is this going to factor? Is that going to factor? I don't think so. I don't think that factors. Oh, order of operations are going to come to our rescue. Right? So since I'm trying to solve the equation, I want to start by undoing any adding or subtracting. Opposite of subtracting 7 is adding 7. Then I want to undo any multiplying or dividing. I don't see any multiplying or dividing. So now I want to undo the exponent. And this is tricky because when I take the square root, I have to remember to do that plus or minus. Just like with the quadratic formula, or just like solving by completing the square, I got to remember to put that plus or minus in front. And so we're going to have 3 answers here. We're going to have negative 7, 2, negative root 7, 2, and then root 7. If you're wondering why they're in that order, square root of 7 is actually a little bit bigger than 2, right? 2 times 2 is 4. So you know root 7 is a little bit bigger than 2. All right, and of course, 2 of our answers came from solving our resulting equation by taking a square root. 1 of the answers came from synthetic division. And if you had done factor by grouping, you would have still needed to use a square root after figuring out one of the answers. Now here, I could try factor by grouping, but factor by grouping will not work. I look at the last term, which is a 4. That is not a perfect cube. So I really have no alternative but to use synthetic division. I'll guess 2. And of course it's going to work because I've got the PowerPoint set up so we'll be successful in the first try. When you're doing the assignment, very seldom do you get it right on the first try. All right, and of course my resulting equation is x squared plus 6x plus 2 equals 0. I just read that from the bottom line, that synthetic division. And so now I just got to think of two numbers that multiply to be 2, but add up to 6. Let me see, they have to multiply to be 2, but they have to add up to 6. This is not going to happen, right? This is impossible. All I can think of for 2 is 1 times 2, and 1 plus 2 is not going to add up to 6. So what on earth can I do? Yes, the quadratic formula. All right, that's going to be my ticket out of here. So I have to plug in my values. And then, of course, there's a lot of step-by-step work that I have to go through. Notice when I get to the square root of 28, I know that 28 is actually 4 times 7. So the square root of 28 is the square root of 4 times square root of 7. We can take the square root of 4 to get plain old 2. And then I can divide, right? Negative 6 divided by 2 becomes negative 3. 2 root 7 divided by 2 becomes a root 7, right? Some skills from first year algebra and possibly even pre-algebra came into play there. So I'm going to get 3 answers. 2 of them came from the quadratic formula, right? I've got an answer of negative 3 minus root 7. And then I've got an answer of negative 3 plus root 7. And then I have my answer of 2, which came from the synthetic division. And those answers are in order from least to greatest. And so we have a cow. Oh, no, it's not a cow. It's a couch potato. No, it's actually time for the worksheet with the emphasis on work. All right, let's get some work done here. Let's not be couch potatoes.